Here's another interesting thing that can be deduced from the relationship between angles and points in the unit circle. So suppose you have an angle, central angle like that, drawn on the plane, and that you consider the corresponding point in the unit circle. So applying the Pythagorean theorem to this triangle, what do you get? You would get that x squared plus y squared equals 1. So x squared plus y squared equals 1, which is this. Now, we also know that y equals sine of t and that x equals cosine of t. So replacing this and that over here in this equation, you would get that cosine of t squared plus sine of t squared equals 1. And this equation is known as a trigonometric Pythagorean identity. It came directly from applying the Pythagorean theorem to our picture, and we replaced the regular x and y, which are the lengths of the sides. We replaced that with the corresponding expression using trigonometric functions, and we got a trigonometric version of the Pythagorean identity. Now, one thing about notation, in trigonometry, it is customary to not write exponents outside like that. So what is traditional is to write exponents like this. So if you have, for example, cosine of t squared, normally we write that like this. Cosine squared of t. So this is the usual way in which we write exponents in trigonometry for trigonometric functions that are being raised to a power. So for as another example, suppose we have tangent of t cubed. We normally would write that as tangent cubed of t. And finally, one last example, if we had cosecant of t to the fourth, we would write that as cosecant to the fourth of t. Okay, that's the usual way in which we write exponents in trig. So then that means that instead of writing this equation like this, we would write it like this. So cosine squared of t plus sine squared of t equals 1. And this is true for any angle whatsoever, okay? And this is, again, the trigonometric Pythagorean identity. And this is an identity that you really have to memorize. This is a formula that is very useful for a variety of purposes. Um, we're going to get into that later, but here's the first application or use of the trigonometric Pythagorean identity. If you know one of sine or cosine, you can figure out the other one. So if you know sine, you can figure out cosine by using this equation. And if you know cosine, you can figure out sine by using that equation. So here's example 5. If the sine of t equals 2/3 and t is in the second quadrant, then what is the cosine? Find the cosine of t. Okay, and the idea is again that if you know the sine, you can put it in here in this equation and you can solve for cosine and figure out what it is. So let's do that. So we're starting with cosine squared of t plus sine squared of t equals 1 because sine of t is 2/3. This equation right here is going to become cosine squared of t plus 2/3 squared equals 1. Replacing the sine with 2/3. Okay, sine squared would be 2/3 squared. And now let's simplify and see what we get. We're going to get cosine squared of t. Squaring that, you get 4/9 equals 1. And then moving the 4/9 to the other side, we're going to get cosine squared of t equals 1 minus 4/9. And simplifying that either by hand or in your calculator, you can do this by hand really easily. that would be like 9 over 9, and then 9 minus 4 is 5. So this is really just 5 over 9. All right, so 5 over 9. So we have that the cosine squared of t equals 5 over 9. And now if you remember from college algebra, you can figure out what cosine of t is by just taking square root on both sides. On the left hand side, the square is going to go. In the right hand side, you get this. But don't forget, though, that there was a rule that you learn in college algebra that whenever you take square root on both sides of an equation, you have to put plus or minus on one side. So actually, then, you're supposed to put plus or minus in there. And now that is correct. The cosine of t equals plus or minus the square root of 5 over 9. And of course, we can simplify this by distributing. You can distribute the square root, that would be square root of the top over square root of the bottom. Square root of the top, which is square root of 5, but square root of the bottom, square root of 9 is 3. So we have this answer. Cosine of t is square root of 5 over 3, positive or negative. That means there's two choices. It cannot be both choices. It has to be one or the other. And this is where this little piece right here comes into play. Okay, so far, we did all this without using that piece of information. Now we're going to use that to decide which of the two possibilities is the real one, is the one that we actually want. Because it cannot be both. It's one or the other. So these are the two possibilities. Cosine of t could be square root of 5 over 3, or cosine of t could be negative square root of 3, negative square root of 5 over 3. So which one is it? All right, let's think. So if you draw a picture real quick, they're telling us that t, the angle t, is in the second quadrant. So somewhere here. So t is in the second quadrant, somewhere there. Now, the coordinates of this point, this is a unit circle, so that radius is 1. The coordinates of this point, we know what they are. The coordinates of this point are the cosine of t and the sine of t. So the coordinates of is x and y, but the x is a cosine and the y is a sine. So the fact that this point is in the second quadrant, it tells me that the cosine has to be negative. Okay, so t in the second quadrant means that t in quadrant 2 means that the cosine has to be negative. But if cosine is negative, that means that cosine of t has to be this one, not that one. So this one is discarded. So that one cannot be, okay? Cannot be because the cosine is negative because the angle is in the second quadrant. So the answer is cosine of t has to be equal to negative square root of 5 over 3. And make sure you understood all of this problem really well because it is a very classical example and I like to include it not only homework but also on exams and the final exam as well. So make sure you really got this one. We're going to do another one though, and I think if you really understood that, you should give this one a try. It says, if the cosine of t equals 24 over 25 and t is in the fourth quadrant, find the sine of t and the tangent of t. So you should pause the video and give it a shot. You know that in order to find, if you have cosine, in order to find sine, you have to use the trigonometric Pythagorean identity. Okay, assuming that you gave that a try and you're back, let's do it. All right, so we start from the trigonometric Pythagorean identity, which is cosine squared of t plus sine squared of t equals 1. Okay, we know what cosine of t is, so we're just going to plug it in there. See what we get. So this is 24 over 25 squared plus sine squared of t equals 1. And now we're going to simplify. Okay, we're going to need a calculator for this. I'm going to put this in my calculator. 24 squared is 576. 25 squared is 625. So sine squared of t equals 1. Now move this to the other side. Okay, move it to the other side. You're going to get sine squared of t equals 1 minus 576 over 625. And simplifying the right-hand side here, you can do this by hand or use the calculator. This is 1 is 625 over 625. So you would have 625 minus 576, which is 49. So you get 49 over 625. And lastly, to get sine, you would take square root on both sides. So we get sine of t equals square root of 49 over 625, but don't forget, you have to put plus or minus. That's the rule. All right, and actually, this can be simplified to distributing the radical, that is square root of the top over square root of the bottom. Square root of the top is 7, square root of 49 is 7, square root of 625 is 25. Okay, so that means we have two possibilities. Either sine of t is 7 over 25 positive, or sine of t equals negative, put 7 over 25. Now, which one is the actual answer? So now this is where we use the next piece of information. The t is in the fourth quadrant. If we didn't have this piece of information, there is no way of determining whether the answer is one or the other. We could say it's either or, but we couldn't simply choose. It would be impossible. But we have that t is in the fourth quadrant. With that information, we can figure this out. So let's draw a quick picture. So we know that t is in the fourth quadrant, right here, somewhere. It doesn't matter where. Just draw it somewhere in the fourth quadrant. That's your angle, t. And if the coordinates of this is a unit circle, the coordinates of that point are x, y, but x is a cosine. So this is cosine of t, and the y is the sine. So the y coordinate is the sine. So the coordinates of that point is a unit circle are cosine and sine. Cosine and sine. Now, so that means the cosine is well, in this quadrant, the cosine is positive. We don't need that, but the sine is negative. In that quadrant, the sine is negative, and therefore the answer is this one. This cannot be right because our angle is in the fourth quadrant. So the answer has to be that sine of t equals negative 7 over 25.